All right. Straight up memory foam on your feet. What is a combination? That's her words. Now, yesterday, we looked at how many outcomes we can get with this race, right? And the difference between this and what we're going to do is that for this one, did order matter?
No.
Because it says if there are 5 racers, how many different podium finishes can there be? Now, if you had 5 racers like A, B, C, D, and E, those are my 5 racers. And then I had A is first place, B is second, and C is third. Or I have A is first, and C is second, and B is third. My question to you guys, are these different?
Yeah.
They are different. Why are they different?
Different order.
Because C is much happier right here than C is happy right here, right? Because they're different. Second place is different than third place. And so, does order matter in this case? Yes, order matters. ABC is not the same as ACB. That's different. Order matters. So when order matters, you can use a permutation. Yesterday I showed you guys this. Now we're talking about 3 spots. And so there's first place, there's second place, and there's third place. Those are the only places that we care about. How many racers have the opportunity of getting first place before anybody crosses the finish line? There's 5. Okay, so 1 crossed the finish line. How many racers can get second? There's 4 and then 3, right? So how many different combinations can we have? Well, 5 times 4 times 3, which is 60. So there's 60 different ways that these 5 racers can finish the race. Well, on the podium, okay? So, what does a permutation look like? Well, this is a permutation, okay? But just so you guys are familiar with the notation so you can use it, NPR, oh, there's a news radio station like that. Yeah, we did. This is the total number, and this is how many you're choosing.
Wait, but how do we go off from there? Like, I understand what to put in it, but I don't get, like, how do you
use it?
Yeah. Like,
Do you understand what I did right here?
yeah, I get that.
Okay, then you would probably just do that instead of using the permutation button on a calculator. It is valuable to know, and it's valuable to understand how to simplify it. But don't stress if you don't fully understand it right away, because it might start coming to you. So the formula for this one is n factorial over n minus r factorial. Now, why is that? Why is it that? Like, and how does this apply to this right here? Well, check it out. This is like a pattern up here, right? It's going 5 times 4 times 3, and it's missing 2 and 1. What is this representing? It's representing 5 factorial. Now this is cut out, right? That's not part of our solution here. So how do we get just this when we're going to use a factorial? Like how,
You subtract what you do.
not subtract, you divide. Okay, so here we have n factorial, which is 5, because that's our total. And then we have to take away 2 factorial, right? 2 factorial. Because 5 factorial is 5 times 4 times 3 times 2 times 1, and we don't want this anymore, so we got to take away that. We got to take away the 2 times 1, right? And if I divide 2 times 1, divide by 2 times 1, they go away.
So that's what you put on the bottom?
Yeah, well, this right here is this, and I'm going to show you why. The n is 5, and the r is 3, because we're choosing 3, right? Because there's 3 spots, so that's why there's a 3 here. We're choosing 3. The r right here is, in this case, is 3 because there's 3 spots. There's 3 times that we're choosing something, okay? And so what do we get? We get 5 factorial on top, and the bottom we get 2 factorial. Oh, isn't that what we wanted right here? Does that make sense? I'm trying to work backwards to help you guys understand it. And so then on the top, you would write it out. You go 5 times 4 times 3 times 2 times 1. And you write it out just so you can see, oh, look, I can cross those out. I get the same thing as this right here. So this is a permutation. This is when order matters. So here's a problem when order doesn't matter. Let's see. Let's analyze it. Okay, it says if there are 6 racers for a race, how many different teams of 3 can be created? Well, let's think about this. So now we have 6 racers, and so we're going to write A, B, C, D, E, F. Okay, so there's my 6 racers. 1, 2, 3, 4, 5, 6. All right, let's make one team. A, B, C. Now, if I change the order of these, I'd say A, C, B. Is it different?
No.
No.
No, it's not. I could also write this as B, A, C, B, C, A. I could write it as C, A, B, and C, B, A. Now, all of these look different, but when you know that they're just a team, it's just one, right? This counts as one. Order does not matter here. It's not like the race, you know? If it was the finishes, like who gets first, who gets second, the order matters there, right? Order matters. Here, order doesn't matter. So how do we change how do we find that out? Well, we have to take out all the extras. So we got to figure out a way to manipulate our formula to take all the extras out so that they're not counted. We can't just do the regular thing that we did before. We're going to choose 3 people for our team, so we're going to say 6 times 5 times 3, times 4. You can't do that, because that's going to include these. This is just like what we did before, isn't it? It's going to include it. So how do we take them out? You divide, just like before. So let's see. So it'd be 6 times 5 times 4, and what do we have to take out of this? So that,
The 5 times.
well, how many did we get right here? We got 6 of them, and we only want that to be counted once, so how do we take the 6 out? You divide it by 6. You get 20.
What about the other letters though? We didn't use the other letters.
Yes, there's other letters, but they're all included in this. Because how many choices do I have to pick for the first one? I have 6, and then I have 5, and then I have 4. Okay? Now that's fine and dandy, and that's I'm trying to show you guys that to help you understand the concept of it. But you can use something called a combination. It's N, C, R. The N and the R are the same as the permutation. This is the total, and this is how many you're choosing. Okay? And so this is what it looks like. You have the N factorial on the top, just like the permutation. On the bottom, you have the N minus R factorial on the bottom. Isn't that just like the permutation? Okay, but there's something more that we're taking out. You're taking out R factorial. However many you're choosing, factorial. So, how would that look for this problem? It would look like this. There's 6 options, 6 total options, and we're only choosing 3 for a team. Right? Okay, so we would have 6 factorial on the top, then we'd have 6 minus 3 factorial on the bottom, and 3 factorial. Well, here, check it out. Check out what happens here. 6 factorial. Okay, wait. What does this simplify to? Just 2 factorial, right? So I go...
Wouldn't it be 3 factorial?
Oh, wait, 3 factorial. Sorry. Yeah, 6 minus 3 is 3. Oh, phew. Saved me on that one. So I have 3 factorial and 3 factorial, and on the top we have 6 factorial. Well, if I go 6 times 5 times 4 times 3 factorial, that will allow me to cross out one of these 3 factorials, right? They 1 out, because 3 factorial divided by 3 factorial is 1. So look at what I'm left with. I'm left with 6 times 5 times 4 over 3 factorial. Do you guys know what 3 factorial is?
6.
Oh, it's 6. And on the top, I have 6 times 5 times 4. We cross those, or cross them out because they 1 out, and we're left with 20.
So
That's how many different teams that you can get. We can get 20 different teams out of, teams of 3, out of 6 people, or 6 athletes. That's it.